If we know that an equation represents a function, then we can put it in function notation. That's what we'll study in section 3.1.4. If y is a function of x, we write y equals f of x. We read that f of x. For example, f of x equals 2x plus 3. F of x and y mean the same thing. They are interchangeable. So this function, f of x equals 2x plus 3, represents the ordinary equation y equals 2x plus 3. But we have function notation. In function notation, f is what we call the function name. If I'm writing a function for area, for example, I might call it a of x. Or if I'm writing a function for revenue, I might call it r of x. It's not a variable, it's just the name of a function. The input in this set of parentheses is called the argument of the function. It represents, again, the input or the domain value. What we have on the right side here, this is what we call the function rule. It tells me what to do to the input. The benefit of function notation is used in substitution. For example, if I want to plug 1 in for x and evaluate f of 1, then I simply plug 1 in for x in the function rule and evaluate. So we determine f of 1 equals 5. So the input is the x value, and the output is the y value. The input is from the domain, the output is from the range. So f of 1 equals 5 is the same thing as the ordered pair 1, 5. So function notation is beneficial and pretty easy to use. Let's try some examples. Given f of x equals the square root of 6x plus 7, find f of 3 and then express the result as an ordered pair. So f of 3 is equal to the square root of 6 times 3 plus 7. So I'm just plugging 3 in for x. Then we can evaluate. 6 times 3 is 18, and 18 plus 7 is 25. The square root of 25 is 5. Thus, f of 3 is equal to 5. 5 is what we call the function value. So when x is 3, y is 5. Or the function value for x equals 3 is 5. This corresponds to the ordered pair 3, 5 on the graph. So function notation is another way of expressing an ordered pair. Example 5, rewrite the following equations in function notation, then find f of negative 2, f of 0, f of negative x, and f of x plus 1. Okay, one thing at a time. First thing I want to do is rewrite it in function notation. To do that, I need to have y by itself. So I'm going to subtract 3x from both sides. We get y equals 4 minus 3x. Then we can replace y with f of x, and that rewrites the equation in function notation. Once we have it in function notation, we can determine the requested function values. To figure out f of negative 2, that simply means plug negative 2 in for x and then evaluate. Negative 3 times negative 2 is positive 6, so it looks like f of negative 2 equals 10. The next request there was f of 0. So to find f of 0, I'm using my original function rule, and I'm going to plug 0 in for x. 4 minus 3 times 0 is 4. So our function value is 4. The next part is a little trickier. We're going to evaluate f of negative x, which simply means I'm going to plug negative x in for x. Now, for a guide, I want to write my function rule directly above what I just wrote down so you can see exactly what changes. Okay, so my argument x has now turned into negative x. So when I see this argument, I'm going to replace it with negative x. So I'm plugging negative x in for x. Negative 3 times negative x is positive 3x. Notice there's nothing to evaluate or simplify, so we are done. Now, I know we're leaving Unit 2, going into Unit 3, and in Unit 2, our focus was solving all kinds of equations. So you may be tempted to set this equal to 0 and solve for x, but that's not what we're doing. We're finding the function value. What that means is plug the argument in, plug in what's in parentheses, and simplify. We're not solving anything, we are just simplifying, okay? Let's try our last one, f of x minus 1. I'm going to plug x minus 1 in where I see the x. So we have 4 minus 3 times. Now I'm replacing the x with x minus 1. And then my goal is to simplify. So I'm going to distribute the negative 3 and combine like terms. 4 plus 3 gives us 7. So plug in the argument and simplify, and that's all there is to it. Hopefully you see Unit 3 is a little bit easier than Unit 2. Okay, doing example B, we're going to rewrite the equation in function notation. In this case, since y is isolated, I'm going to replace it with f of x, and there is my function in function notation. Then I can find the requested values. The first one, I think, was -2, f of -2. So I'm going to plug -2 in everywhere I see an x. First, I'm going to record the negative from the given function rule, and then I'm going to replace x with -2. Okay, so notice we've got some negatives to wrestle with here. Now, I'm going to evaluate the exponent before I multiply by the negative. So this guy's going to wait patiently. Then, -2 squared means -2 times -2 or +4. Okay? Then, on the next step, I can do the multiplication. -4 minus 8 plus 1. And finally, we can add left to right. We have -12 plus 1, or -11. So f of -2 equals -11. Next, we can evaluate f of 0. Finding f of 0, we plug 0 in for x. 0 squared and 4 times 0 is 0, so f of 0 equals 1. Then we can move on to f of -x. So everywhere I see the x in the original function, I'm going to replace those with negative x's. So I'm going to copy the negative from the formula. Then I'm going to replace x with -x in both spots, and then simplify. Okay? Remember order of operations. We're going to evaluate the exponent first. -x times -x is +x squared. This negative comes down and waits patiently. We've evaluated the exponent, so we end up with -x squared. 4 times -x is -4x, and there's nothing left that we can simplify or evaluate, so we are done. Remember, don't set it equal to 0, don't solve for x. We'll eventually do that, but now our goal is simply to plug it in and simplify. Let's finish with f of x minus 1. Looking at the original function as my guide, everywhere I see those boxes, I'm going to plug in an x minus 1. And then all the other operations stay the same. Okay? Now we have to simplify this one. Be really careful that you do not distribute this negative until you have evaluated the square, okay? Exponents precede multiplication. Now, to square, I'm going to need to do some FOIL. So we're going to multiply that out with FOIL. We're going to need our distributive property on the second step, and then we'll combine like terms. Now, being very careful here, I'm going to negate the result of this FOIL product. So I'm going to keep all the FOIL results in parentheses. First is x squared, outside is minus x, inside is minus x, and last is plus 1. Okay, while we're here, let's go ahead and distribute our 4 to get 4x minus 4. On the next step, we'll combine our two middle terms here, x squared minus 2x plus 1. Let's combine our constants here. Finally, we're ready to distribute this negative that's been waiting so patiently. So we get negative x squared plus 2x minus 1 plus 4x minus 3. And last, we will combine like terms. 2x plus 4x gives us 6x, and negative 1 minus 3 gives us negative 4. So f of x minus 1 has this as its output, and that is all we're doing. We've plugged in the argument and we simplify. The very last example in this section is learning to evaluate functions from a graph. So we're looking at the graph of a function. Notice we do not have the equation or the function rule. We just know this is some function f of x. And we want to find f of negative 2, f of 2, and 6. When I find f of negative 2, I'm recognizing that the input value is negative 2. Remember, the input represents a value from the domain or a value of the independent variable x equals negative 2. So I'm going to find the point on the graph that has an x value of negative 2. This is ordered pair negative 2, 1. We could say when x is negative 2, the corresponding y value is 1. So f of negative 2, therefore, equals 1. Okay, it's very simple when you know what you're looking for. Let's make sure we all know what we're looking for. F of 2. The input is 2. Remember, what's in parentheses is the argument or the x value. So I want to find the point on the graph that has an x value of 2, and I want to observe its corresponding y value. Since the ordered pair is 2, 0, f of 2, therefore, is 0. We could say when x is 2, y is 0. Let's finish with one last evaluation, f of 6. That means I want to find the point on the graph with an x value of 6. And I want to observe its corresponding y value. So the ordered pair of this point, x is 6, y is 9. Therefore, you tell me, what is f of 6? I'm going to assume that you are correct, and you said 9. Good job.